right, everybody. Well, thank you so much for joining us today. If you need closed captioning, you can simply click on that CC button located at the bottom of your Zoom screen. You may need to click on the More option to open additional options if you don't see the CC option right there. My name is Lauren Wittick, and I am the Communications Specialist for Region 4, which is based out of the University of Utah's Spencer S. Eccles Health Sciences Library. Region 4 is made up of 9 states, which are Arizona, Idaho, Colorado, Montana, New Mexico, North and South Dakota, Utah, and Wyoming. Trying to get my slides to, there we go. A few housekeeping items before we get started. By registering for this session, you have agreed to the NNLM Code of Conduct. We ask that you please keep your questions and comments respectful. And this just allows us to create a welcoming learning environment for all. We will be recording today's session. Please note it can take up to 30 days for us to edit and caption the video and upload to YouTube. However, we'll send that link out to the recording to all registrants when it becomes available. We're also going to share a link to the evaluation, the session evaluation, toward the end. Completing this evaluation is the first step to claiming your MLA continuing education credit, should you be interested in doing so. And finally, we ask that you enter your questions into the chat as you think of them. We have reserved some time for Q&A at the end. Moving on, our next Region 4 webinar will be held July 2024. We're going to make an announcement on our webpage as well as our blog and our weekly newsletter with registration details once we have a speaker scheduled. We don't have a webinar in May. However, we're going to have NNLM Day at MLA on May 2nd, 2024, between 12 and 4 p.m. Eastern Time. And each of the NNLM regions and offices, including Region 4, will highlight activities from the past year and share upcoming programs that NNLM members can look forward to. Just please check the NNLM training calendar page, which is nnlm.gov/training in the coming weeks for specifics. If you'd like to stay up to date with Region 4, we encourage you to sign up for our newsletter or visit our blog. The QR code shown here on the slide will take you to our regional page, which is simply nnlm.gov/region 4. If you live outside of Region 4, I encourage you to head to NNLM's webpage to find and connect with your respective region for additional training, funding, and outreach opportunities in your area. Now, I want to welcome our guest speaker, Chris Guerra. Chris is the State Data Coordinator and Project Specialist for the Arizona State Library, Archives, and Public Records. His work deals primarily with library-related statistics and technology education. As an avid gaming enthusiast and self-proclaimed geek, he spends a lot of time online and would likely be the first to fall in an apocalypse due to lack of internet access. Chris, the floor is yours.
All right, thank you very much. I'm going to go ahead and share my... There we go. All right. Well, greetings, everyone. I really appreciate you taking the time out to join me today for this discussion on generative artificial intelligence tools. Now, I would like to think that this is a hot topic. And if you watch the news or you read the technology section of your local newspaper, you might certainly feel inclined to say that it certainly seems that way. Yet when I talk to people in my daily life, I find that the number who have used or are considering using generative AI tools seems proportionately low. To some degree, I believe that's the result of people just not having a clear understanding of how it might be used in their day-to-day setting, right? So what is the benefit? What are the risks? What is the cost? And perhaps most importantly, at least at the moment, is it worth the effort? And while I can't say whether my presentation today will definitively provide you with an answer, I would like to think that it will at the very least help you to better understand why it's important to pay attention to. Because generative AI, along with the vast landscape that is AI in general, is most certainly here to stay. And it's very likely that it will, if it hasn't already, intrude in your life in one way or another. Now, getting to the core of today's presentation, my aim is to explore the concept of generative AI, which is a significant branch of artificial intelligence that's currently reshaping how we approach creativity and problem solving across various domains, including the biomedical field. To that end, the agenda is structured such that it's going to take us from the foundational aspects of generative AI through to its practical applications and ethical considerations that comes with its advancements. So we're going to begin by defining what sets generative AI apart from other AI technologies, touching on the core principles and the technological backbone that supports it. We'll then dive into specific tools such as ChatGPT, the recently renamed Gemini, previously known as Bard, DALL-E. I was originally going to talk about Midjourney, a similar application to DALL-E, but realized it would make more sense to showcase something I currently personally have access to, and Stable Diffusion. Then we will take a brief look at some use case scenarios in the field of healthcare and biomedicine. And from there, and because as the proverb popularized by Spider-Man says, with great power comes great responsibility, we're going to end by addressing the ethical implications of utilizing generative AI, from privacy concerns to data bias, with a particular focus on how it might relate to the information science profession. So with that, let us begin. Foundations of generative AI. So unlike traditional artificial technology systems, which primarily analyze and interpret data, generative AI goes a step further by producing new original outputs based on learned patterns in data. So this can range from generating realistic images to composing music, writing text, and just about anything else you can imagine that can be generated digitally. The generative aspect signifies the system's ability to create something new rather than simply categorizing or responding to existing information. But to really understand how this works, you first need to be familiar with a few core concepts and technologies, notably those which form the backbone of generative AI. And those key concepts and technologies are machine learning, deep learning, models, specifically large language models, and algorithms. Now, machine learning is a branch of artificial intelligence that focuses on creating systems capable of learning and improving from experience without being explicitly programmed for specific tasks. Deep learning is a cutting-edge technology within the broader field of artificial intelligence, and it's distinguished by its ability to learn and make decisions by mimicking the way the human brain operates. At the heart of deep learning are neural networks, and these are complex algorithms arranged in layers, hence the term deep, with each layer capable of recognizing different aspects of data. So from simple patterns to intricate details. And this kind of structure enables deep learning systems to process vast amounts of information, learning from examples to perform tasks such as recognizing speech, identifying images, or understanding natural language. And unlike traditional computer programs that follow explicit instructions, deep learning models improve their accuracy and adaptability by directly learning from the data, making these incredibly powerful tools for solving a wide range of challenges where human-like cognition is beneficial. Now, models, particularly large language models, are advanced computational systems designed to process, understand, and generate human language in a way that mimics human-like understanding. Built upon the foundation of machine learning and deep learning technologies, these models learn from vast collections of text data, enabling them to compose sentences, answer questions, and even create content that feels surprisingly human. LLMs stand out due to their massive scale, both in terms of the data they're trained on and their intricate network structure, which contain billions of parameters that help capture the nuances of language. And the capability allows these LLMs to perform a wide array of tasks, from translating languages to generating creative writing, making them ideal tools for applications where any kind of natural language processing and generation are crucial. And finally, algorithms, at least in the context of generative AI, are the sets of mathematical instructions or rules that are designed to enable these computers to create content that mimics human-like outputs, like images, text, music, or even synthetic voices. These algorithms learn from vast amounts of existing data, identifying patterns and styles and structures within the data to generate new original content that shares similarities with human-made originals. So as you can see from these definitions, there's a lot of overlap and connectivity regarding their functionality. So let's try to put them together within the scope of AI. And this is my attempt at explaining it in a visual format. So we begin there in the bottom left corner with algorithms, which act as the fundamental set of instructions for solving problems with machine learning, being a subset of artificial intelligence, where these algorithms are specifically designed to learn from and make predictions on decisions based on data. Deep learning, which is a further subset of machine learning, specializes more heavily in algorithms that model complex patterns through deep neural networks, enabling advanced levels of data interpretation and decision making. The models themselves are the tangible outcomes of these algorithms, and they're tailored and trained for specific tasks, embodying the learned data patterns. So within the realm of deep learning, large language models represent a sophisticated category of models specifically engineered for processing and generating human language, utilizing these massive neural networks and extensive data sets to achieve the human-like understanding I keep mentioning. And so from the foundational algorithms through the layers of machine learning and deep learning to the specific implementation in models and the specialized domain of large language models, there exists this hierarchical and interdependent relationship that drives the evolution and capabilities of these AI technologies. Now, if all of this seems overwhelming, all I can say is I feel your pain, because no matter how many times I dive into these components, I tend to just come away with more questions. What I'd want to say is that the main takeaway from all of this is that there is an incredible level of complexity in the design and implementation of these technologies, which means that there's a lot going on under the hood that ultimately determines the final products that they generate. And one other thing that I really need to mention, as I keep alluding to, is that these technologies operate on data sets. And it's the quality and quantity of data used to train these generative AI models that are so vital for their performance. Training data, as it's often referred to, needs to be comprehensive and diverse enough to enable the models to learn a wide range of patterns and nuances to ultimately be able to create novel outputs. Essentially, the data serves as the foundation upon which the generative AI models build their understanding and creative capacities. So if you look at the data set for one popular generative AI tool, OpenAI's ChatGPT, it's rumored to have been trained on data comprised of some 300 billion words from various sources on the internet, including the Common Crawl. And for those of you who aren't aware, Common Crawl is actually a nonprofit organization which regularly performs crawls of the web, hence their name. And they take snapshots of billions of web pages. And then they make this information freely available to researchers, developers, and just about anyone else interested in analyzing or utilizing the information. Now, of course, the Common Crawl isn't all that ChatGPT and these other generative AI tools learn from, although there is no public information that shows us the full scope of their source data, which of course has led to its own controversy. Now, before we jump into some specific tools, though, I want to give you a better idea of how some of these models train, because I think understanding their different approaches can provide you with at least a sense of what underlies their capacity to generate unique output. And to do that, I'm going to share with you 4 notable models using imagined scenarios as analogies to help you better understand the way that they work with data. The first type of model I want to talk about are called generative adversarial networks, or GANs. And they operate on this principle of 2 competing networks, a generator that creates data and a discriminator that evaluates its authenticity, and then working together to improve the quality of generated outputs. So for an analogous scenario, I want you to imagine 2 librarians with different roles. One librarian is an aspiring author, and we'll call them the generator. And the other librarian is a discerning critic. We'll call them the discriminator. The aspiring author writes new stories, trying to make them as realistic and believable as possible, using inspiration from a vast collection of existing literature. The critic reads these stories and compares them with the real books in the library, deciding whether each new story is genuine or a clever imitation. Now, initially, the aspiring author's stories are easy to distinguish from the real ones. However, with continuous feedback from the critic, learning which parts of the story didn't seem authentic, The author improves, making the stories increasingly difficult to distinguish from the real ones. Simultaneously, the critic becomes better at detecting even the subtlest clues that mark a story as an imitation. Now, this process continues until the aspiring author can produce stories so convincingly that the critic can barely tell them apart from the real ones. In the world of AI, this means that the GAN has successfully learned to generate new data, like images, music, or text, that are almost indistinguishable from authentic data. The second model type I want to talk about are called variational autoencoders, or VAEs, which are based on the principle of encoding inputs into a latent space and then decoding them to generate new outputs. Now, in this comparative scenario, I want you to imagine a VAE as a project to create a digital library archive. The goal is to take the essence of each book, its core themes, styles, and content, and compress it into a much smaller digital representation. This process is akin to an expert librarian, who we'll call the encoder, summarizing each book into a concise abstract, capturing its most important aspects while leaving out unnecessary details. Once the book is summarized, another librarian, the decoder, takes the abstract and tries to reconstruct the original book as closely as possible. The better the summary, the more accurate the reconstruction will be. However, it's of course a challenging task, and the reconstructed book might not be a perfect match, but it should still capture the essence of the original. This type of process not only helps in efficiently archiving vast amounts of literature, but also allows for the creation of new books. So by tweaking the summaries, or in AI terms, the encoded representations, new books can be generated that share characteristics with existing ones, but are entirely novel creations. The third type of model that I want to share with you are called autoregressive models, with one example being generative pre-trained transformers, or the GPT part of ChatGPT. These work by predicting future values in a sequence by learning from previous ones. So in this scenario, let's imagine that you're telling a story to a group of listeners. And with each word you say, your audience guesses what you're going to say next based on everything you've said so far. Autoregressive models like GPT work in a similar way, but instead of stories, they're dealing with data. These models look at a sequence of data, words for example, and predict the next piece of the sequence based on what they've seen before. So it's like playing a sophisticated guessing game where the model gets better and better at predicting as it reads more data. Now think of GPT as a voracious reader that's gone through a massive library of books covering every imaginable subject. By reading so much, it learns the structure of language, the way stories unfold, facts about the world, and even styles of writing. When you give it a prompt like the beginning of a sentence, it uses everything it's learned to continue the story in a way that makes sense based on its reading experience. So this is like a librarian who, after years of reading and organizing books, can recommend what book you should read next based on your interests and what you have read before. In essence, GPT and similar models are like digital librarians with an encyclopedic knowledge of the text that they've been trained on, capable of generating new content that mirrors the style, structure, and substance of their training data. They're not just repeating what they've read, they're creating something new, much like a storyteller weaving a new tale inspired by a lifetime of reading. The last type of models I want to discuss are called diffusion models, which learn to generate data by reversing what is called a diffusion process, that being a process where noise is gradually added to data until it turns into a random noise distribution, and then learning to reverse the process to generate data from noise. This is the type of model that the text-to-image generating tool Stable Diffusion, which I'm going to talk about today, is based on. To better understand this particular model, I want you to imagine you have a large, disorganized collection of books and information that you want to organize in a meaningful way, transforming it from a state of chaos to a state of clarity and usefulness. Diffusion models work in a somewhat similar way, but in the realm of digital image creation or text generation. They start with a process akin to introducing noise or randomness into a clear and structured data set. So imagine randomly scattering the books in our analogy. Then, through a series of steps, they gradually remove this noise, refining and shaping the data, or in our analogy, organizing the books, back into something structured and meaningful, guided by the patterns that they've learned from vast amounts of data. In the context of generating images, for example, a diffusion model begins with a random pattern of pixels, like our disorganized collection of books. And over many steps, it gradually refines these pixels, reducing the randomness or organizing the books until it forms a coherent and detailed image that corresponds to a given description, being a well-organized library. Now, this process is guided by the model's understanding of how images are structured, which it's learned from seeing millions of examples. And this method is incredibly powerful for generating new content because it's flexible and it can produce highly detailed and varied outputs, whether images or text. So just as a librarian might draw upon their vast knowledge of literature to recommend a book that perfectly matches a patron's vague request, diffusion models draw upon their training to create content that matches the input they're given. So in thinking of these four models, I hope you're starting to notice a sort of underlying process, one in which the models are essentially looking for new ways to understand the foundations that determine existing patterns so that they can use these techniques to create new, yet coherent based on their request, outputs. Basically, they're teaching computers how to be creative in the same way that humans are creative, albeit limited by their current components of technology and information. Now, with all that in mind, let's take a look at four existing and relatively accessible generative AI tools: ChatGPT, Gemini, DALL-E, and Stable Diffusion. Okay. At the end of November 2022, a new product was made freely available to the public called ChatGPT. And although we didn't know it at the time, it would effectively herald in a new wave of discussion and innovation around AI, most notably generative AI. Now, the exact reasons why the application was brought to the public, especially at no cost, has been somewhat debated. Some say that it wanted to be first to market and to promote their brand. Some say it was because they needed the public to help test the product. And yet others say it was to get people hooked so that they would later become paid users. I am one of those people. But whatever the reason or reasons, its popularity was immense, as in 2 months from launch, it had already hit 100 million users, making it the fastest growing user base at the time. But what is it that made ChatGPT so popular? Well, at its core, it's the fact that not only could you use it to answer questions and perform all sorts of tasks, but you could do so in a way that was easy for people to interact with. And that's because it communicated in a way that was familiar to us, using natural language. And it seemed to know a lot. It often felt like Google search if it was a person and could quickly and politely answer all our questions without first shoving ads in our face. Of course, whether what it said was correct or not would be a topic for study in the months following. And really, that's what's at the heart of what makes these four applications we're going to talk about so alluring. That they are, for the most part, both readily accessible and intuitive, with some exceptions, to use, and that they perform their task quickly, and that they are, with some caveats, completely free. So let's dive into ChatGPT. Now, ChatGPT is a text-to-text generative AI tool, meaning that you input text and you get text as an output. It operates on what you might think of as a chatbot, where you can ask it specific questions or ask it to perform certain tasks. Accessing the software is as simple as going to this URL there, chat.openai.com, and signing up for a free account. And once you're in, you're free to utilize what I will call its base features, meaning that you're using the next to latest iteration of its software, and that you won't have the opportunity to test out any beta features it might currently be offering its paid subscribers. And just as an FYI, if you want to subscribe, it is $20 a month. And while there is a bit more to ChatGPT than just its basic text-to-text prompt box, including the ability to have it read uploaded documents for synthesis or uploading images for analysis, for today, I'm going to focus on its more prevalent feature. So what I'm going to do is I'm going to ask it to perform some tasks based around the major modes of functionality that people are most likely to employ it for. And also, just as a heads up, I'm going to use these exact same prompts when I test out Gemini, since it's the same type of tool. That way, we can see how the two systems might differ in their responses. Also, I am using ChatGPT 4.0, which is more akin to Gemini Advanced, Google's pay version. So it's not going to be a perfect comparison. I don't have a current subscription to Gemini Advanced. But now let me go ahead and transition to my live account. So let's see, I'm going to share, and I should have it open. And there we go. So right now we are in my live version or my live account for ChatGPT. And you can see here on the top left that I have selected 4.0. I can regress back to 3.5. There are some advantages in terms of speed, but in terms of quality, there's just, unless you're being limited for some reason, which can happen sometimes where just because of the sheer popularity, they tell you you've done too many asks, too many tasks in a day, there's really no reason not to use the latest version. So the first thing I'm going to do here on the bottom is I'm going to enter some pre-made prompts that I've done. And the first one I've written is, write a simple explanation of how mRNA vaccines work for a general audience. And I'm going to hit go. Now, I will say, even though this looks like it's acting quickly, the reality is 3.5 is way faster. It's so fast that basically the moment you click, you're going to have your answer. But again, those answers are not going to be as comprehensive. So let's see what it's writing. So it's saying their vaccines are a new type of vaccine to protect against infectious diseases. It tells you to understand how they work. It gives you a little bit of a summary. Says here's where mRNA vaccines come in. They stand for messenger ribonucleic acid, and it's essentially a piece of genetic code. And it goes on and on. Basically, it did what you would think you might see in a summary of like a Wikipedia article, right? It just provides me a nice summary in relation to my question. Now, again, I'm not saying whether or not what it's telling me is correct. As I mentioned before about the GPT model or those autoregressive models, really these types of software are designed to just focus more on sounding natural and realistic, and they were trained on data that likely included this information, which is why it can answer it. But this is not a search engine, right? It's not guaranteed to be pulling accurate information, so it's something you always want to check. For the second prompt, just to see a little bit about its language abilities, because one of the things I found is that ChatGPT works as a better translator than something like Google Translate. And the reason why is because GPT is trained to consider context. Whereas something like Google Translate, it's almost like trying to do a one-to-one translation. ChatGPT looks at the whole of what you're entering. Now, in this case, it may not. We're going to see what it does. Okay, so see, I specifically said, give me a Spanish translation of an abstract, but it's saying, sorry, I don't have an abstract. So what I'm going to quickly type in is, please translate your, and how did I phrase that? Your explanation of mRNA into Spanish. Unexpected server error, regenerate, try to. And here we go. Now, I chose Spanish because I can kind of speak it, but I can tell you right now that my Spanish is not good enough to know whether or not this is truly an excellent translation. So I will leave it to others to consider. But as you can see, though, it's doing it, and it does it in all sorts of different languages. It's not restrictive to any specific ones. And while that's printing, I'm going to go ahead and get my third prompt ready. Okay. And it's still going. Okay. I'll wait for it to, there we go. And it's asking if this response was better or worse because it had the issue before where it needed to regenerate. And so sometimes you can give it feedback and tell it why something worked or didn't work. For the third prompt, I'm going to say, outline key points for a presentation on the impact of telemedicine in rural communities. Now, these are the kinds of things that I find ChatGPT to be really good for. It's good at creating what I'll call simple and broad foundational work towards things like coming up with outlines or plans, or here in this case for a presentation. It works as a nice starting point in the same way that Wikipedia was a nice starting point for information, but you wouldn't use it as the final product. So here again, it gave me this breakdown. It got the introduction to telemedicine. It then has challenges faced by rural communities, benefits of telemedicine in rural areas, and on, challenges, case studies. And so it's a pretty, that seems like a pretty good and comprehensive outline for such a thing. Now, one of the other things that I have used ChatGPT for is I've used it for coding. I've used it to make Excel macros, which may not be considered coding, and to do web pages with PHP and JavaScript. So what I'm going to say right now is write a Python script to calculate the body mass index from patient data. Let's see what it does. In this case, it's thinking a little harder than usual. You can see the wheel going. It could be because of the fact that I'm not feeding it any patient data. Let's see, here we go. That is not at all what let's see if this actually gives me, oh, and here we go. So they've changed the way the format works. It used to be that it would populate the code directly into the result page, but it looks like they created like a little shortcut here. So here we go. It's created some code for me. I obviously can't say whether or not this is well done. Like I said, the stuff that I've used in the past for the JavaScript and the PHP has worked very well. I've never had code that doesn't work, but that is not a guarantee. But again, that's just something else that you can use ChatGPT for. And for the last one, and this is something I know people use it for all the time, whether they're creating lectures or assignments or something of that nature, I'm going to ask it to create a quiz for healthcare professionals on medical terminologies. And again, the good thing about this is it's creating the quiz very quickly. It gives you a place to start with. The bad part is I have no idea whether the answers to the questions that it's setting are even accurate. So again, as I will keep reiterating over and over again, don't necessarily trust it, but again, use it as sort of a starting point. And I could try telling it to do things like do a certain number of questions. I have found that these generative AI tools like ChatGPT are very funny in terms of counting. Like if you were to say, write for me a 10-page paper or a 1,000-word paper, it wouldn't do it. It would do something, but it wouldn't be 1,000 words. And it seems like as soon as you go over 100 words, it starts to lose count. So yeah, it's a little funny with that. So if you're thinking you can get a very specific set of parameters that you want to feed it, you may or may not. That's questionable to go with. But jumping really quickly back into my slide. Oh, did not want that. Share screen. Go back to. I need to rerun my slideshow. And 1 second as I get back to, I know I'm not sharing it at the moment. I'm going to just get to where I need to go. And okay, now I'm going to go back into Zoom and share. Okay, share screen. And gotta love Zoom. Is that the PowerPoint? Yeah, I think that's it. There we go. Okay. So, okay. Now, as with all popular things, someone out there needs to make a competitor, right? And to that end, the most parallel product to ChatGPT is Google's iteration, originally called Bard and now renamed to Gemini. Now, for the most part, they're the same type of product. They are both text-to-text generative AI. They both offer free and subscription-based access, and their use case scenarios are the same. What differentiates the two tends to be both what technologies are running under the hood, as well as how they're being rolled out to the public. So as I mentioned previously, ChatGPT is based on the GPT, or Generative Pre-trained Transformer architecture. And Gemini, on the other hand, is aimed to leverage Google's Lambda, which stands for Language Model for Dialogue Applications. technology, which is supposedly designed to produce more conversational and contextually aware responses. We will see how that goes. Also, as opposed to OpenAI's creation of an entirely new and separate product with the ability to connect it to other applications through APIs, Google is attempting, as you would imagine, to integrate Gemini into their already existing suite of applications. So for instance, while Gemini does not directly search the internet for its answers, there is a built-in Google It feature, which will allow you to see search results related to Gemini's responses so that you can verify the information or perform further exploration. Now, it's just as simple as with Google, with ChatGPT. If you want to use Gemini, you just need to go to that URL there, geminigoogle.com/app. And if you're not already, I do think you need to have a Google account, although I feel like all of us have a Gmail account, so we all have a Google account, so we can do that with no problem. And then I'm going to go back really quick to oops, that's the slide. Which one's my browser? There we go. And then I've got open in another tab. So here we are in live Gemini, and this is again using my own Google account. It's got a bunch of notices. It's basically telling you that your information is being reviewed because again, we're the, what's that saying? Like if you're not paying for the service, you are the product. So of course they benefit from us using it for free. So I'm going to go ahead and copy in some of the same prompts that I used before. So first I'm going to ask it to go ahead and again write me that explanation for how mRNA vaccines work for a general audience. And let's see how it does. And I like this one. It's, so the question was to do for a general audience. If we go back really quick to ChatGPT, it was a very, whoops, that's a Spanish one. A very formal kind of thing, this thing you might read in a paper, a summary. But this one, I like the way it starts with, imagine your body's a factor in your immune system security team. This does seem more friendly, I would say. So I think it's really taking to the casual audience bit a bit better than ChatGPT 4.0 did. And now I needed to copy what it said before for the Spanish one. So I'm going to say, please provide a Spanish translation of that above and see how it does. And it's thinking. Unfortunately, I cannot access and translate. Oh, whoops, I copied the wrong thing. Let's see. Please translate. I copied the wrong thing. That's on me, not Gemini. Let's try that again. Please translate your explanation of mRNA into Spanish. Whew. That's a lot faster. Again, my Spanish is not good enough, at least my reading capacity, to say which is better. But again, both of these tools are free, at least the 3.5 version of GPT and this Gemini I'm using. So if you ever want to go in and see how they compare in terms of their accuracy, that would be an interesting thing to do. And also see what type of Spanish it's using, because that definitely differs from place to place. Now I'm going to go ahead and ask it to outline key points for the presentation, like I also did with ChatGPT. So outline key points for a presentation on the impact of telemedicine in rural communities. And all that's going a second. Let me scroll down to what it gave us here. And let's see. Well, this is taking a little longer than it usually does. I may restart or refresh the browser and give it another shot. Usually it doesn't take this long. So let's refresh. Go back. Try again. There we go. Okay. Introduction, what is telemedicine, impacts in rural communities, challenges and considerations. This is awfully similar. I will say that the ChatGPT one seems to have a few more sections. It looks to be a bit more detailed. Again, this is not Gemini Advanced, so maybe if I had the paid version of Google, it might give something more akin, but yeah, that's not too bad. I'm going to now try the Python script one. So again, I'm asking it to write a Python script to calculate the BMI of patient data. Let's see what it says about patient data if it asks me for some. There it is. And so this is the way I thought it was going to populate in the other one. Now, again, I don't know Python. But as you can see how quickly it did, and I'm sure if you do know Python, you can go ahead and paste this into something so that you can actually run it and see how it works. And then the last one is I wanted to create the quiz for healthcare professionals on medical terminologies. Oh, I like the format of this better. Just really quick, I'm going to jump back over here so we can see. So this is the way it did it in ChatGPT. The prefix to, oh, these are good. But again, this is one of those things where I have no idea where if it's accurate or not. Let me see if I can do the Google it. Double check response. And go ahead and click that and see what it does. And it's evaluating it based on search data. Understand the results. Here we go. Similar content that's likely different. So did it highlight stuff? I'm not seeing any highlighting. Okay. Well, that's not something I've really played. Oh, maybe it's this drop down here. Okay, so here we go. It's got one saying green Google search found similar content like this. So it's saying it seems pretty obvious. And then when I click on it, it goes to the actual source. So that's nice. I should mention that ChatGPT, it's really weird about this. So with ChatGPT, if you're a subscriber, you have access to beta features. And one of the beta features they rolled out for a while was the ability to connect to the web, but not everyone got it. So my supervisor with her account has it, and I don't. To me, that's one of the key principles, right? We need these tools to interact with real sources of data, not that everything on the web is real or accurate, but just as an improvement versus just the training data used. But in any case, that's a discussion for another time. I'm going to go back now to, let's see, where is my PowerPoint slide? There we go. Okay. All right, so let's move on to our final two products. So a text-to-image generative AI tool is just like what it sounds like, right? It's a tool where you enter text that it uses as a prompt to generate an image. And there are text-to-video tools as well. OpenAI's Sora is one that I can think of that's coming out soon, but those are not yet easily accessible, and they're not something that I've had any notable opportunity to actually test. So I can't really speak to those. But as those come up, just it's going to be nuts once those become accessible to everyone. In any case, within the current marketplace, probably the three products, text to image products you're likely to hear about are going to be DALL-E from OpenAI, again, makers of ChatGPT, Midjourney, which happens to be another San Francisco-based company that came about in 2022, and Stable Diffusion, also released in 2022. It was apparently a good year for generative AI. And of these three products, I currently have access to two of them, although for one of those two, Stable Diffusion, I can only show you the screenshots because unlike the other two commercial products that operate solely online, Stable Diffusion is actually an open source product that I run locally on my personal computer. And because it runs almost exclusively through the strength of the graphics card, my work laptop, which I'm using right now, would cry from the effort. And that's assuming my work would even let me install it there in the first place. But before I get into a live demonstration, I want to talk about some of the realities of using these kinds of tools. For one, I need to note that there are some obvious advantages and disadvantages between using commercial products and the open source one. And these are pretty much in line with what you would expect based on their mode of availability. So with commercial products like DALL-E and Midjourney, you're far more likely to get a decent looking and generally well-polished product with your prompts. And that's because the companies that run these applications have done some extensive work in the background to make it so. This is not true of Stable Diffusion, where your first iterations, if you ask it, for instance, to generate a person, are likely to look like monstrosities right out of a body horror film. And yes, this is a real image that I generated through Stable Diffusion with just a basic prompt, and it was horrible. However, the advantage of Stable Diffusion is that you can ultimately have full control over how the image is being generated with lots of settings to tweak, and even several add-ons called LoRa's and things like that to help navigate your prompt towards the type of image you want. And in addition, there's no restriction to the type of image you can generate, whereas with commercial products, the companies running them are often trying to navigate that fine line between allowing their customers flexibility to use it as they want and having their tools being used to create questionable, controversial, disturbing, or even outright illegal images. Now, that said, there are some typical, what I'll call errors that can often happen with AI-generated images, as you just noted with my Stable Diffusion monstrosity, especially when it comes to people. And the most notable are that AI have often struggled with both human mouths and appendages. Many times, for instance, giving people an extra set of teeth or more than 2 arms or 5 fingers per hand. But most of the time, these products are just amusing, and with some careful adjustments to the prompt, they can be avoided. Now, for the purpose of demonstration today, I'm going to exclusively use what I have immediate access to, which is DALL-E. DALL-E can be subscribed to separately from ChatGPT. However, as a ChatGPT subscriber, I was given access to their image generating tool within the ChatGPT interface for free. So that's what I'm going to use today. Also, I tried to think of some image prompts that might be applicable to you all. However, I can't say what kinds of results I'm going to get with what I came up with. So this is going to it's going to be a surprise for all of us. So let me go ahead and go once again. Whoops, back to share my browser. There we go. Now I'm back into, now I'm in ChatGPT, and just because of time, I'm just going to do 2 image requests. The first is I'm going to ask it, create an image of healthy human heart alongside a heart affected by coronary artery disease in a style suitable for educational textbooks. And I will say that image generation, it's going to give me 2 choices. Sometimes it gives me multiple choices to pick from, and sometimes it just gives me one. I have yet to figure out why it does one over the other, but it's actually going pretty quickly, so we'll see how that goes. And again, these images are not things that you can edit after the fact. Every image you get is basically a novel image, so I can't be like, oh, that was great. Can you redo that, except do this or do that? And so here, it gave me 2 responses, and they're not bad. This is actually better than some of the stuff I've been getting recently with DALL-E when I try to ask for something educational. I want to look at the text, though, really quick. Yeah, those words, they look like real words, and sometimes they are, and sometimes they're not. It's not doing so well lately, I've noticed, with text. But that's one example right there. And then one other I'll do is, let's see, I'll do display it. Okay, this is going to be my next prompt. I want to ask it to design an infographic on the importance of hand washing to prevent the spread of infectious diseases suitable for display in public health facilities. Now, as I mentioned, one of the things you never have to worry about with the commercial products is it doing something inappropriate. These things, they err very much on the side of caution. So there is no way, and if there's anything with the terminology or verbiage in your prompt that it thinks is worrisome, it will simply say, sorry, I can't do that. Although people used to be able to trick it to do it anyway, but the algorithms have gotten better at not being tricked into doing things that it's not supposed to. So again, let's see. Well, it looks like the kind I would see in Office, but again, you'll notice that the words are not necessarily words. So this is something to consider. Again, the artwork is great. The text is not. And these things are really fun to play with. But like I said, just due to time, I'm going to go ahead and instead go back to my presentation so I can make sure to cover everything I wanted to cover today. There we go. All right, I want to talk about, oops, there's my mouse. There we go. I want to talk about some generative AI use case scenarios. So different professional sectors or fields tend to have their own unique types of data, which would need to be at the heart of any generative AI tool's training for it to be applicable. And as it so happens, there are in fact several large language models that are being utilized specifically in the healthcare and biomedical fields. And these include BioBERT. BERT stands for Bidirectional Encoder Representations from Transformers. And this one's specifically pre-trained on large-scale biomedical data. It supposedly excels at tasks like disease prediction, chemical protein interaction, and biomedical named entity recognition, which is supposedly aids in improving the understanding of complex medical texts and research papers. There's also Clinical BERT, which is used for clinical notes and is optimized for understanding electronic health records. It's particularly effective for tasks such as predicting hospital readmission, patient mortality, and extracting clinical information from notes. You've got GPT-3 for healthcare, and which, as the name would imply, has been custom tailored for healthcare applications such as medical question answering, generating patient information leaflets, and creating medical educational materials. You've got Bluebert, I love these names, which much like BioBert is trained using biomedical and clinical texts. It has shown promising results in various natural language processing tasks, including named entity recognition, relation extraction, and question answering over biomedical literature. And then you have PubMedBert, which is specifically trained, as you would well imagine, on PubMed articles, and it's optimized for biomedical text mining. Supposedly, it outperforms models that are just pre-trained on general domain information for tasks like named entity recognition, evidence-based medical information extraction, and other biomedical natural language processing tasks. But as you can see, the point is relevant databases are being used to train applicable generative AI tools. So then what are some of the more prominent use case scenarios of the tools these LLMs would underlie? So the first is drug discovery and molecular design. So generative models like generative adversarial network and variational autoencoders that we previously discussed are being used to design new molecules with desired properties for drug development. The hope is that this will significantly reduce the time and cost associated with discovering new drugs by predicting the effectiveness and safety of molecules before synthesizing and testing. You've got personalized medicine and treatment plans. So by analyzing patient data, hopefully anonymized, generative AI can simulate how different treatments might affect an individual, helping to tailor medical interventions to the patient's unique genetic makeup, lifestyle, and disease state. You've got medical imaging and diagnosis. So generative AI models are being trained to augment, reconstruct, and generate medical imaging data, hoping to improve image quality and enable better diagnosis. So for instance, in situations where MRI or CT scans are inconclusive due to low resolution or noise, AI can be used to generate enhanced images that can help radiologists make more accurate diagnoses. And it can also be used to generate synthetic images for training diagnostic models, helping to overcome issues limited to real patient data due to privacy concerns. Got protein structure prediction, so they can be used with deep learning to predict the 3D structures of proteins from their amino acid sequences. You've got synthetic data generation for research and training, so it can produce synthetic healthcare data that mimics real patient data, therefore preserving privacy while allowing the researchers and healthcare professionals to conduct different studies and training without risking patient confidentiality. And then you've got content generation for patient education and support. So it can be used to generate personalized education and support content for the patients that would include things like explanations of their conditions, treatment plans, and health management advice. Ideally, this would improve patient engagement and adherence to their treatment protocols. And enhancing clinical decision support systems. So it can be used to simulate clinical scenarios based on patient data, assisting in line development of decision support tools that can provide recommendations or predict outcomes of different interventions. And this could help clinicians make informed decisions and improve their patient outcomes. And really, this is just the tip of the iceberg, depending on how nuanced you want to get with these use case scenarios. There are certainly plenty more, like assisting with all the related administrative tasks involved in healthcare, like appointment scheduling, billing and claims, processing, insurance verification, et cetera. So in truth, though, these applications of generative AI are broad and far-reaching, and it's really only a matter of time before we see in which areas they gain the most traction. And apologies, I'm talking really fast, just because I have a bit to get there in like 7 minutes. Okay, so now that we've established at least a very general understanding of what generative AI is, we've had some opportunities to see it in action, and we've considered some use case scenarios in healthcare and the biomedical field. Let's talk about what's at the heart of much of the debate with AI, which is namely the ethical challenges. So generative AI, by its very nature, raises profound questions about the origins and ownership of content, the potential for bias in automated decisions, and the implications of AI-generated content on our perceptions of truth and authenticity. And as these technologies become more ingrained in our daily lives, from creating art to making decisions that affect real human lives, the ethical considerations they prompt become increasingly complex and multifaceted. And there's more I wanted to say, but really it's just more of a summary of what I'm about to talk about. So let me just jump really quickly to some of the concerns that I think stand out most for those of us working in the information science fields to be aware of, especially if you're considering adopting any generative AI technologies. And I want to begin with accuracy and reliability. So AI models, while sophisticated, are most definitely not infallible, and they can potentially generate responses that are inaccurate or misleading. This can be due to limitations in the model's training data or misunderstandings of more complicated questions. As such, you should always be cautious when using AI for definitive answers, especially in areas that require some level of specialized knowledge. It's crucial to have a system in place to verify any AI-generated information, as well as to educate your patrons about its potential for inaccuracies. Data privacy and security. So these AI tools raise, as mentioned, significant concerns about data privacy and security. Libraries obviously have a responsibility to protect patron data, which includes interactions with these AI systems. So it's important to understand and communicate how user data is being stored, processed, and potentially shared by these. And of course, whatever you do, it needs to align with your library's privacy policies and legal requirements. One thing that OpenAI has done to help address these concerns is they released what's called ChatGPT Enterprise, which is essentially a business or organization-focused version of it that silos information away from OpenAI and can never be used for their research purposes. There's also bias and ethical considerations. So AI models can exhibit biases that are present in their training data, which can lead to skewed or unfair responses. And this is particularly concerning in a library setting, which aims to provide unbiased and equitable access to information. So you need to be aware of the potential for AI to reinforce stereotypes or marginalize certain groups. To avoid the issue, you should do regular audits for biases and provide training on ethical AI use. Misinformation and content appropriateness. So AI-generated content has the potential to inadvertently spread misinformation or inappropriate content. And this is an obvious concern for libraries, which are trusted sources of information. There needs to be mechanisms to review and filter any AI-generated content, especially in contexts involving children or sensitive topics. You're going to want, therefore, develop guidelines for AI use to ensure that the content aligns with your community standards and informational accuracy. Dependency and skill erosion. So an over-reliance on AI for information retrieval and content generation could most definitely lead to a decline in traditional research and critical thinking skills. You should encourage a balanced approach, promoting tools like ChatGPT or Gemini as supplementary rather than a replacement for human judgment and skills. It's important to continue teaching and valuing those fundamental research skills alongside the use of AI. Digital literacy and user understanding. So not every library patron is going to be familiar with AI and how it works. There's an obvious and well-documented gap in digital literacy, which can lead to misunderstandings or misuse of these tools. However, you can take this as an opportunity to educate your patrons about AI, including how to interact with it effectively, understand its limitations, and critically assess the information it provides. And this could be part of like a broader digital literacy initiative. A big one, intellectual property and copyright, AI-generated content, particularly summaries or creative writing, can raise a lot of questions about these two things. You're going to have to navigate these complex issues, making sure that you're respecting copyright laws and the intellectual property rights of creators, especially if you use AI to generate or repurpose content for public use. And then finally, cultural sensitivity. Public libraries serve diverse communities, and it's important that the tools you use are sensitive to this diversity. That includes understanding and respecting cultural nuances and responses, avoiding cultural biases, and ensuring inclusivity in the AI's interaction with users from different backgrounds. You need to be sure to actively look for AI solutions that have been trained and tested for cultural competency inclusivity. And these are just the ones that I can think of right now. There are certainly many more that are going to become prominent as the technology evolves and as it sees more widespread adoption in our fields. However, it's never too early to start thinking about them because there's no doubt that AI is going to, at the very least, augment, if not outright replace, some of the services we currently offer. Okay, well, we've explored some pretty complex topics today very, very, very quickly. My biggest hope, as I mentioned before, is that you'll at least begin to understand how generative AI might shift the existing landscape around creativity, problem solving, and data analysis, particularly in our fields. And that you've seen how, while not terribly sophisticated right now, the tools have reignited this discussion around AI that's going to likely develop and mature in the near future. And also keep in mind that the tools we have access to do not necessarily reflect the capacity of those being used at larger scale. So simply put, Generative AI is here to stay, and as information professionals, it's wholly within our responsibility to keep abreast of their developments. So I encourage you all to use this presentation as a jumping off point to researching these topics in greater detail. Go and test the products, become familiar with their strengths and weaknesses, and be ready as the general populace starts exploring them to be able to address their questions and concerns. And most importantly, be involved, because not just generative AI, but AI in general, as I mentioned, requires a group effort to ensure it works for us and not against us. In any case, and I want to thank you all for your time today, and please let me know if you do have any specific questions with whatever time I have left. And I chose alpacas just because I love alpacas. This has nothing to do with AI, and these were not created with AI.
Thank you, Chris. We have quite a few questions. I don't think we're going to be able to get to all of them, so I'll just pick a few. And then if folks have questions that they didn't get answered, you're always welcome to email us at region4@nnlm.gov, and we would be happy to pass those questions on to Chris. The first question we have is, we kind of touched on this a little bit. Any clauses we should be careful of in end user license agreements before setting up an account with these AI sites? Just wondering what we are potentially signing away when we use these tools.
So one of the big things, as I talked about when I asked, why did ChatGPT or why did OpenAI release ChatGPT for free, is the fact that the data that you enter into it is technically viewable by all. There was, in fact, a case scenario, I'm trying to remember who it was it Samsung or LG or something, where someone in the company put in information or question related to work within the company, and then someone else completely apart from any of this was able to ask questions that gave them the information that was entered into it. So that's why you definitely want to sign up with an enterprise and organization-based service and not just use their free stuff with work-related stuff that isn't meant to be on the public domain, because you never know who's looking at it. So yeah, absolutely, there are some things I would test it for personal use. For any work-related stuff, I would check with your administrator and or see about getting a professional license, and then working, of course, with your IT, who should know just how well and effective those are.
The next question is the translation function better with certain languages versus others?
I wish I could answer. Like I said, the foundation of what seems to make it better, and I've tested it with Japanese, Spanish, is that it understands context. So it's looking at the whole of what you're saying rather than just at the words, which you may notice things like Google Translate do. In terms of does it do better with some versus others, I wish I could say, but I don't know. As far as I can tell, it seems to be work with the same language sets, but I don't have the skill set to answer that directly.
Mm-hmm. Can you get the references or where the information was pulled from? And I'm assuming they mean the references of what ChatGPT or the other generative AI tools use to create.
Oh, sure, absolutely. Yeah, I will go ahead and do that. Mm-hmm.
Oh no, can the actual generative tool provide those references?
Oh, I see what you're saying. So
Yeah.
no, the answer is, and this is awful, this is one of the things it's terrible at, is if you ask it for citations, it will give you answers. And remember, auto-regressive like ChatGPT models, they work by wanting it to sound right before they care about whether it's right. And in fact, I think I mentioned to Lauren beforehand, there was a case where a lawyer pulled citations from ChatGPT of some cases, and they were all made up, and they used them, and they were either fined or debarred for it. I can't remember which ended up happening. So the problem is, again, these are not searching actual databases. It's rather that they were trained on this information, which is why they know so much, but it doesn't mean that they're pulling literal sources right now. So yeah, I would not use it for citations or references. It will give you them, just not right.
What, if anything, makes the healthcare AI tools better than the ones available to the general public?
Mostly, as I was saying, it's the data sets they use. So again, the foundation of what makes these work well is the data that they're pulling from, what they're being trained on. And there's just, from just basic things like jargon to the types of data sets, data files, the kinds of things you work with on a regular basis, that these are trained on to better help them understand the way people in that field think and talk and understand different words and contexts. And so it just makes it more focused on those. They're trained exclusively on those type of content. So you assume that they would be better within those exclusive fields. Although I do want to just quickly mention that one of the things you can do with AI like ChatGPT is you can use it like a wrapper, where if you have like your own data sets of information you want people to have accessible to, you can then wrap something like ChatGPT around it to use it as an interface to pull from your data sources. So you don't necessarily have to use a sophisticated software that uses these like medical LLMs. You can just use your own data, which we kind of are wanting to do soon.
Right. I think we got time for one, maybe two more. Let's see here. How would you appropriately credit AI generated verbiage or images?
So I'm actually going for my MLS right now, and this was brought up. Someone, one of my professors, and I'll have to look to see exactly how they did it. They did have a specific a mode of citing it, and it's not APA. I know that it's not. I've checked the APA guidelines, and it's not there, so I'm not sure exactly where she put it. And the question is really, and I think this is still in the courts to some degree, when you do cite, who do you cite, right? Because the problem is GPT or ChatGPT or other text-to-text generative tools were trained on other people's data. So technically, do you give credit to them? Well, you can't because, right, you don't have access to it. So you need to give credit to the tool itself. But there's a question about whether that's fair. But as far as there being a format, supposedly there's one out there, but I can't find any yet in professional information sources for referencing.
Right. I think we're at time. We're a little past our hour. So I just want to thank Chris so much for taking the time. There are plenty more questions. So again, please email us at region4@nnlm.gov and we can pass those questions on to Chris and he would be happy to help you.
I would absolutely.
Thanks so much for being with us today. Have a great day.
Thanks for watching. This video was produced by the network of the National Library of Medicine. Select the circular channel icon to subscribe to our channel, or select a video thumbnail to watch another video from the channel.